In this episode,
DC powered electricity, that stuff won't let you go if you grab it.
In a nutshell, please don't do that.
Stop fiddling with it. Stop changing the settings.
and the next question to them was, well, where is this Y strainer?
Compressor stops generally approximately 2 starts per hour.
Most of the time it will be measuring low flow rate through the heat pump, and then that's what will throw the alarm out.
Get rid of the control manufacturers. They won't be here much in 5 years' time.
Because not all systems do contain glycol.
Has a much higher flow rate than, say, Valent, for example, on the same kilowatt output.
Welcome to Homeowners Q&A. In this episode, we're going to troubleshoot some common heat pump issues, whether it's dealing with fluctuating temperatures, unusual sounds, error codes, or efficiency drops. Understanding how to identify and address issues can help homeowners keep their heat pump systems running smoothly. I'm your host, Mars, and today we have an expert panel here to guide us through the most common heat pump problems. Joining us are Rob Stevens from Heatforce, Michael Dungworth from NIBE, and Martin Perrin from Design Me a Heat Pump. Welcome, everybody. But before we get stuck in, we'd like to say a huge thank you to NIBE for sponsoring today's episode. We appreciate NIBE's dedication to supporting homeowners in understanding and optimizing their heating systems, especially when it comes to troubleshooting and maintaining peak efficiency. NIBE's commitment to renewable heating solutions that are both reliable and efficient is helping homeowners in the UK navigate the transition to sustainable energy with confidence. Thank you once again, NIBE, for helping us to empower homeowners to get the best out of their heat pump systems. So, Martin, when it comes to the most common heat pump issues, what do you typically find, troubleshooting-wise, is the biggest issue that homeowners face?
Flow error is the biggest one. It's usually down to installers haven't flushed the system correctly. There's loads of muck in the system. The filter gets blocked. Out it goes on a flow error. So depending on what manufacturer, come up with different errors. Like Daikin is 7H. LG is CH14. They all have their own dedicated number, basically.
Is that something, Rob, that you would actually communicate to the actual homeowner and advise them to maybe clean out a blocked filter by themselves? Is that a potential solution?
From an installer's perspective, we get a phone call from a person saying that their heat pump has gone out on alarm, and like Martin said, going out on low flow is probably the biggest call that we get. We'll provide a homeowner with a handover guide, so it will have a list of common, easily resolvable issues that might be down to things like maintenance. So it could be, I can't get the heat pump screen to unlock, for example. That's one. So how to unlock the screen, how to remove and clean the particle filter. So the first port of call is always to try and guide them through it using the handover. So they've got that information 24 hours a day if they need it. If you're dealing with perhaps like a person that isn't perhaps confident or comfortable following guidance to remove the filter and cleaning it, then it might be a case of us coming out and doing it. But it will be part of the routine system maintenance that the homeowner is guided through when the heat pump system is handed over at the end of the installation. So
from a manufacturer's perspective, Michael, the Y strainer is pretty much on most heat pump systems. Is that something that from a manufacturer's perspective, you instruct the installers to do, to actually put Y strainers into their systems?
Yeah, so as a manufacturer, it's definitely something we fundamentally supply with all our products, really, is the Y strainers and return strainers with the micron baskets in there to collect any debris or anything that's running around the system, either from particularly the installation or even over periods of time where you might find any sort of deterioration if, for instance, inhibitor weren't installed or on the water quality within the system. So yeah, that's definitely something we ask the installers to check. And to reflect what Martin and Robert said, it's certainly something that is a common sort of information message or fault, as it were, on our systems. And I think it's key having the ability to interpret the control system to see what the fault that is being raised, rather than what you would receive in a handover pack,
Touch wood, our heat pump has actually run quite well, but it was the second Christmas, it was actually Boxing Day, that our heating went off and we had an error on the panel, and it was kind of panic stations on our part. So, it was getting on the phones. Thankfully, the support team were actually taking the calls that day. Look, it's probably your Y strainer that's blocked. And the next question to them was, well, where is this Y strainer? Where is it located? We then had to close the isolation valves, clean it out, which thankfully, once we did, it actually started to work properly again. So Rob, is that something that you guys would do as part of a commissioning handover? Is it advisable to actually show homeowners where this Y strainer is and how to actually isolate the system and how to clean it out properly?
it definitely is, as I said, for the more technically savvy homeowner. With heat pump systems, they need to be regularly maintained. There aren't quite as many moving parts as there are in, say, a gas boiler, which is one of the benefits of them, but they do need to have regular maintenance, and normally as part of the warranty for the system. So as a general rule, we will set up a servicing plan with the customer where it's an annual servicing provided by us, by Heatforce, and that is something very commonly that a lot of installers will do. So we will show the customer where the key parts of the system are, again, things like the electrical shutoff, the isolation points, all the really key bits, and advise them that, look, you can remove this part and give it a little clean if you're comfortable to do so. Cleaning the wise strainer, it's fairly straightforward once you know how to do it, but it's just that initial bit. So we will show them where that part is, and explain that it does need to be cleaned out, as long as it's not, for example, a very old system, and as long as it has got some form of inhibitor in it, then it can be okay to just do it at the annual servicing.
So Martin, we actually had a question from a homeowner. They said they're suffering from low flow rate errors persistently on their heat pump system. Could it be related to a faulty sensor as opposed to necessarily being the actual Y strainer being blocked?
Normally it is a flow error would be a filter block. Even worse, it could be blocked circuits or, with underfloor heating. There is flow sensors and flow monitors on all these heat pumps now. Many years ago, when they first came out, it was just literally like a little paddle flow switch. There is no indication of what the actual flow rate is. A great thing with most of the new heat pumps now is we actually get a reading of flow litres per minute. And so when you arrive at a potential flow issue, you can actually put the system in like a pump purge mode, and then you can check the flow rate. You can go to the filter, see how blocked it is, and then you can clean it out, and then you can check that flow rate again after you've cleaned the filter. So you have a good indication whether that has actually caused the problem or not. There is minimum flow rates we need. It might be that someone's fiddled around with the system if there's bypass valves that are required for different zones. These days we should have open zones, so we shouldn't really, once that system has been installed and commissioned correctly, we shouldn't really have a flow error unless there is muck in the system. We really encourage the installers to really give the system a massive flush through, put inhibitors in, and then we shouldn't really get a problem. And every time you go and service it, that filter shouldn't really be blocked up much.
Carrying on with the same case, this particular homeowner, I think they had one of these Fernox filters installed on the systems. They've taken it out, they've cleaned it. It seems to be clear, and they keep having this low flow rates error. They've now spoken to one installer who says that this flow error might be caused by undersized pipework. Does that sound viable, Mike?
Yeah, so definitely undersized pipework, and system design is paramount with any low temperature heating system, and it's certainly paramount when you come into the retrofit sort of market, and that is something installers should and generally do take into consideration when doing system design and installation. It's not always indicative of what your primer is and flow and returns might be from a heat pump, but it could be something on the existing system that you've retrofitted on. So it's certainly, yes, pipe sizing, even things down to bends and where the actual root of the pipe work goes as well can certainly be effective of flow, as with any sort of hydraulic type system, yeah.
This homeowner has also got a buffer tank. So now what I'm trying to figure out, so the flow error, is that happening from the heat pump into the buffer, or is it happening on the distribution side? Where does the flow error typically trigger?
Most of the time it will be measuring low flow rate through the heat pump, and then that's what will throw the alarm out. I thought it was interesting as well what Michael said about that it could be something to do with the pipework. In that case, it would be probably the primary pipework that was running to and from the heat pump, especially if they put the heat pump on and use the existing boiler pipework that might have been running out into the house. Because I think we spoke a couple of weeks ago, didn't we, about the differences in flow rate, the requirement of wider bore. For example, I know Samsung is one of them, has a much higher flow rate than, say, Valent, for example, on the same kilowatt output. It would be interesting to know as well if it's a recent installation, because as the gents have both said, if you get a flow rate error on a heat pump that's been installed for a while, it's probably something blocking it. But if it's a brand new system that's only just commissioned, then that it could be something blocking it. But that would also raise whether or not it's something to do with the pipework diameters, and also when that error is occurring. Is it occurring when the heat pump is modulating up, when it's trying to run a much higher flow rate, when it's running harder? Because that would, again, suggest undersized pipework. It'd be something for an installer and a designer to look into for the customer.
So I guess flow errors occur because they're there to protect the heat pump. So what you said, Rob, makes perfect sense. So the flow rate drops through the actual heat pump. That's what it's triggering, saying, there's dramas here, there's something incorrect, there's something that's not right. I'm going to shut myself down if this doesn't get rectified. So anything that kind of happens post buffer tank in this instance, the heat pump doesn't really care about, because if the distribution is poor on that side and then coming back into the buffer and going back to the actual heat pump unit, is that remotely correct?
I think what I was just about to say is I think it's very indicative of how the installation is from a buffer perspective, because there are multiple orientations of how buffers can be piped. Many installers that prefer different orientations is kind of what I'm alluding to, is that you have the 4-pipe type buffer, which is kind of complete separation, through to like the volumizer, where it is just sort of if the full system was shut down, i.e. underfloor heating, for instance, then you would have some level of return without the system shutting down because it's got no flow at all. So that's why maybe the buffer's been installed in on that predominant installation. And additional, moving on to probably the next questions that you've got regarding defrosting and things like that.
Planning to install an air source heat pump? Then get your copy of Bodge Buster. It's packed with must-ask questions, real homeowner insights, and a practical guide for a smoother installation. Available in print and on Kindle. Link in the description.
So Michael, when one actually has to clean the filter out, there might be glycol in that system. If you do empty that into a bowl, for example, what is the safest way of disposing of that?
The first thing I would address is, it does depend on the manufacturer, because not all systems do contain glycol. I must admit, our product doesn't advise to have it in there. So it would be just sort of what we would consider sort of potable water, really. But it does contain inhibitor, which again is the substance. If it did have glycol in it, quite often it depends on what the manufacturer of the glycol is, because certain glycol manufacturers have different procedures in disposing. There are manufacturers out there of glycol or antifreeze or brine, we call it, that are safe to dispose of through your normal manners. Others have to be disposed of as per the manufacturer's instructions, which may be, carefully.
You've actually raised an interesting point, because I've kind of always used the word glycol with inhibitor almost in one sentence, but they are clearly two different things.
Glycol or brine or even antifreeze, depending, it's in itself to prevent the system from freezing up. Very similar to like your car. It has coolant in there, which is essentially antifreeze, which is brine and glycol. So, when the cold days, when your car's been sat overnight and then you got to start up in the morning, it's not a block of ice in the engine. Very similar analogy really with the heat pumps is some manufacturers recommend having it in there to prevent that. That is glycol itself. Generally on our systems, you generally only find it in what we call our ground source units range, and not necessarily in the air source. Then an inhibitor itself is corrosion prevention. Essentially, it stops any sort of deterioration of metallic components within system, which then can be broken down and then ultimately collecting that gauze that we mentioned earlier on the Y strainer.
That actually segues us quite nicely. We've got a question on the forums yesterday, Rob. Maybe you can field this one for us. The homeowner says they basically drained one of their radiators and they've purchased a 5-liter antifreeze inhibitor bottle. Is there anything to stop them just draining 5 liters from one of the other large radiators and then directly adding the mixture to that radiator? Is there any reason to premix the glycol?
In a nutshell, please don't do that. To explain why, though, glycol is a more dense fluid than water. So one issue when you're commissioning heat pumps is you need to make sure that the glycol and the water in the system mix. And that can be a bit of a challenge depending on how you designed your system. There are heat pump specific TRVs and various different bits you can buy to allow good mixing through the radiators, but a part of the commissioning system is balancing the radiators and making sure that the glycol has mixed properly through the rad. So the installer will go around the property if you've got radiators and will check the same thing on the side glass on the underfloor heating to make sure that that system is fully mixed. We come with our big trundling mixing tank, the filling machine. We get 2 pipes that will get connected onto the outside, generally the outside of the property if you don't want glycol everywhere. That will allow you to then fill the system. So it's a flush and fill essentially on there, and then you will flush the system with water. You will then start adding your glycol. You'll be checking the solution, the color on the return as it's coming back, doing that multiple times, checking your watch, having your lunch, all those kind of things, which what we're doing when we're filling the system up like that. If you were to just put glycol I don't even know how you would do that into a radiator, to be honest with you. I'm trying to think of the logistic. I'm trying to think about how the practical logistics of that would even work. If you were to just put straight glycol into the system, what you would likely get is a layer of glycol that is just sitting at the bottom. It would mix eventually, but you would get such a variation in performance. So if you do need to top the system up for any reason, and that's something that your installer will let you know. They'll say, look, we need to top up with a bit of glycol, and they'll bring a little device with them called a refractometer. Put a little dose in, you look at it like a pirate, and it will tell you in there what the protection level is for the glycol. So that is the best way to check, and it is a specialist bit of equipment. The installer would need to come with a specific flushing machine to actually dose the glycol and mix it through the system, and then check the concentration before they leave to ensure that the system is adequately protected. So please don't put glycol into the system.
So, Michael, as homeowners become a lot more au fait and familiar with their systems, there's a lot of buzzwords that float around, and short cycling is one that a lot of people have now picked up on. Could you just explain what short cycling is and how homeowners can identify whether, in fact, their heat pump is short cycling or not?
Short cycling essentially in itself means that the unit has not performed its full cycle it was expected to do. So it was shortened that cycle, which essentially means, because he's got compressors in there, it essentially means that compressor started and it shut down before it was expected to. We measure that, or it can be measured generally in stops and runs, or run hours and starts and stops, and then you can granularity bring that within in hours. So we tend to advise that compressor starts stops generally approximately 2 starts per hour, heating and then sort of hot water is kind of the average. A short cycling system would be indicative of something might be stopping 4 times an hour, 5 times an hour. And then ultimately what that does is it reduces the life of your compressor. The best analogy to use is the low and slow method. It's better to run it for longer at a slower speed than it is to continually keep ramping it up and then stopping, and then ramping it up and then stopping.
So, Martin, I guess my follow-up question to that would be, if you're a homeowner and it's December, it's cold outside, the heat pump's running, the house is warm, how would you actually know whether that heat pump is short cycling or not?
I mean, you should hear it start up and start and stop quite often. Once the house gets up a temperature, that is when it will start short cycling. Everyone's banging on about, open zones. Get rid of those controls. We don't need those thermostats in every single room. Get rid of the control manufacturers. They won't be here much in 5 years' time. You will pretty realise that you'll hear that compressor stopping and starting.
So, Michael, we have a question from another homeowner, and they basically ask, how can I use the display panel to understand my heat pump's error codes and if there's something wrong? And as a follow-up to that is that we often find that a lot of heat pumps have got what I would call blanket error codes. So one error code could mean 4 different things. So how can this homeowner use his control panel to better understand what each error code signifies?
The first thing I would say is get the user manual, understand your control system, because that is paramount. Our systems all have a big green or red light on it, and it'll tell you when there's something wrong with it, and it'll say you have one or more notification or you have one or more alarm, and you click on there and you can actually open it up and it'll read out what that potential alarm is. And as you said, Mars, that it could mean within that one alarm code or that information message, and I'll use an example, high pressure, which generally relates to low flow. Within that, as you said, there could be multiple reasons why, and that's kind of a lot of what we've just touched on previously with flow, block strainers, air, low expansion vessel or pressures, microzoning where everything's shut down. But yeah, within that, there could be a multitude of reasons why, but the granularity isn't always there.
You mentioned going to the manual, and I'm not going to bash one particular brand because I always typically do it. I'm normally quite fair and very not biased, and I won't mention them today. They are notorious for getting error codes that are not in the manual. What does the homeowner do? Apparently, a lot of the installers actually do know what they mean, but they are not publicly available. So what does a homeowner do then? Is there only recourse to pick up the phone and phone the manufacturer?
If it's certainly not contained within that user manual, then, and your first protocol would be the installer, because quite often you find the usual culprits. Contact the manufacturer, and they generally have a hotline system, or there might be information you can log in online. So for us, we've got the NIBE uplink platform, my uplink platform, and you can click on there and there's an assistant on there. You can type a code in and it'll give you a bit more granularity and information on what to do, what to try. And if it is something more fundamental, the manufacturer should be saying contact your installer. And depending on the level of expertise of the consumer, the homeowner, then you might not want them removing covers and panels. We've got to remember inside these units is DC powered electricity. That stuff won't let you go if you grab it. As much of as much as AC will also give you a bit of a tingle. So I wouldn't advise sort of removing and start picking and poking in there unless you are what we consider competent. The alarm codes are there to certainly advise you on what the potential fault could be.
Have you got questions about heat pumps and renewables? Then head over to the forums at Renewable Heating Hub for practical advice from thousands of fellow homeowners and heat pump users.
This homeowner says, I get an intermittent compressor overload error. What does this mean? And how do I safely reset my system if this occurs?
It could be to do with like refrigerant problem, so it could be low on refrigerant, so it's having to ramp its power up more. Could be a inverter board problem.
The compressor overload generally can, in my experience, can be a number of things. I mean, all compressors have like a thermal cutout on there. So there's like a little device that sits on the compressor or in the body of the compressor that's constantly measuring temperature. And as Martin said, if it was short of refrigerant or if there was a big demand, the compressor gets hotter, it works harder, and it has a limit. You know, what it doesn't do is cook itself to the point. So that thermal cutout could break, and that could be one of the reasons why you're getting that alarm code and that information. Additionally, the overcurrent of the compressor could be that whilst during it was operating, some manufacturers actually have facilitation to monitor the voltage and current amperage draw of that compressor at time of operation, of which if you have get power spikes or fluctuations in your supply or dips, then that could do it. So it was interrupting while it was operating. It wasn't a steady flow of electricity and current to the compressor, which then it could throw out a fault.
This homeowner basically is having issues with their defrost mode, which is running excessively. And not only is it running excessively, it's running incredibly long, where it takes up to 90 minutes for the defrost cycle to complete. I'm guessing that's not right. And what could potentially be causing that particular issue?
Could be a defrost sensor. That's one of the most common ones. If it's always done it, then it could be an installation fault, too close to the wall or not enough free air in front. That air's recirculating around. That will cause regular defrost modes.
Yep, as Martin said, there's all of those. There could be an airflow issue around the system where it's not able to draw enough air. It could be that the coils on the back of the unit are dirty, is another one as well. There could be an issue with the reversing valve. It's probably not quite as common when the heat pump's trying to run in its defrost cycle.
So I guess that the 90 minutes is an excessively long time for a defrost cycle to complete. So that in itself is an issue. So they should pick up the phone, speak to the installer and say, look, this is taking way too long. Can you come out and have a look at it?
If it does do a defrost, it's reversing the cycle. So the coil that you can see outside is getting warm to defrost any ice build-up on there. And essentially, the component within the unit that would normally be getting hot to distribute heat around, that's getting cold. And whilst that is getting cold, it's paramount that you maintain a level of heat from system, i.e. what's from your buffer or in your wider system, to maintain a minimum flow line temperature so that it can continue its cycle. And quite often, if that isn't, you tend to get attributed alarms to say failed defrost, or it could just be continually running because actually the delta T's of that temperature flow and returns are very close to its minimum operating.
So Martin, as we head into the cooler periods and into the winter, a lot of homeowners keep a lot of tabs on their heating systems. What should they do if they notice a sudden increase in their heat pump's energy consumption? Is that to be expected because it is getting colder? And if it is, what kind of proportion should your heating and electricity consumption be going up by when it does get colder?
Yeah, I mean, the heat pump consumption is going to go up as the temperature gets colder. It's the same as, oil boiler will use more oil. But, the way we are running systems now with, like say, an open zone and very low and slow, certainly the mild temperatures, we're not really seeing massive increase in running costs. But if you've got a sudden spike in running costs, then, there potentially is something wrong. There's something else going on. I think a lot of homeowners now are really conscious about what their running cost is. They're constantly looking at their bills. Again, it's, I suppose, new technology. It's too easy to monitor everything now. You're going to see quite a sharp rise if there's a problem. It might be a case that, the immersion heater on your cylinder is gone into automatic or emergency mode or something like that, But normally most heat pumps won't go into like emergency mode unless you tell it to. There is various settings on some heat pumps so you can automatically switch to an electric backup heater or electric immersion, but most of them it will lock out first, come up with a fault, and if the fault can't be resolved, it will say do you want to go into emergency mode? So then you're going to be expecting high running costs.
The one thing that I've very much extracted from this conversation is that there are kind of two sets of error codes or issues that homeowners might run into. There are some of the easier ones, maybe like a flow rate, which does require, cleaning out the gauze filter, small things that most homeowners should potentially be capable of doing. And then there's the stuff where you actually have to pick up the phone your installer to try and get some sort of assistance to see whether you can get your system up and running faster. Rob, what general advice would you offer to homeowners to maintain their heat pump better and avoid any potential error codes?
I think the biggest one is regular servicing. A lot of people, I think, that have boilers don't necessarily get their boiler serviced every single year. With a heat pump, for several reasons, it's really crucial. It's number one, so that the system can have a health check and any issues can be picked up on before they do become major issues. Cleaning things like the filters, making sure that the outdoor unit is kept in good condition as well. Don't pile things on top of it. Don't grow a tree around it. Don't put a box on the top of it, things like that, to just make sure that it is actually kept nice and clear, making sure that however the condensate is being drained out is clear as well. Make sure that there's no leaves and dirt and debris and things like that.
What about you, Martin? Would you have anything to add to that in the form of advice?
Stop fiddling with it. Stop changing the settings. Yeah, I mean, I had a customer a few years ago that, bless her, it was just her weekend home, so she absolutely refused to keep a background temperature. We advise really 16 degrees background temperature all year round. She'd come down for the weekend on the Friday. It was like 5 degrees inside the house, and within 5 hours expected it to be 21. An old little cottage. Listen to your installer, listen to the person who does your handover, take some advice from them on running the system, and hopefully they've been adequately trained and give you the right advice. Like with a boiler, you just sort of switch it on, you expect it to heat your home within 5 minutes, and heat pump won't do that. Don't touch the settings, and as Rob said, really just keep the area clean. If you're in an area with lots of trees, especially this time of year, the autumn leaves falling all over your heat pump, just brush them all away from the unit. Make sure you get it adequately serviced every year.
What about you, Michael? What advice would you give from a manufacturer's perspective?
Understand your control system and not fiddled with it too much. There are always going to be occasions where you might want to turn the temperature up and down, but there are a lot more granular settings and changes you can do in there that can detriment the operation of the system. Speak to your installer. Quite often your installers, whilst they've installed it, they don't just want to install and run away. They want to be there to support you through the journey of owning a heat pump, because it's not just fit and forget. It should be that full journey.
Do you need help understanding your heat pump? Then pick up a copy of From Zero to Heat Pump Hero, an essential guide offering practical advice and basic instructions for new heat pump owners to maximize system efficiency. Available in print and on Kindle, link in the description.
So a big thank you to Michael, Rob and Martin for walking us through the most common heat pump troubleshooting issues, and our special thanks go out to NIBE for supporting today's episode. But before you go, please hit the like button and subscribe. Until next time, stay warm, stay green, stay tuned. Goodbye.